Okay. Now, moment of inertia, when we use this moment of inertia when you have a composite body or rigid body, right? Now, particles, if you see the object as particle, then the effect of mass you can ignore. But if you see this one as rigid body, or component 1 plus component 2, component 3, then there will be a mass inertia. Okay, if you push the object, if you push the object will continue to move or stop because of the inertia, because of the energy. So today we will do the last chapter, moment of inertia. There are two methods. We'll use parallel axis theorem. And then, of course, you need to apply integration in the process. Okay. Moment of inertia, when you go into dynamics, you just need to refer to table, but you are doing static. So, yeah. So static, you need to know how to derive the equation, right? Now, moment, when you have a distributed load on the body, especially submerged in the water. So when you submerge in the water, the pressure is uniform for all the surface, right? And as you go deeper, then you have more pressure on the surface. So you have an integration form. Integration of y squared dA is a moment of the loading about the axis. But anyway, I will skip this one. If you're interested, you go to read. I won't ask you on the derivation. Okay. The pressure is, you use the specific weight of the float multiplied by the weight is pressure, right? Newton over meter. So the rest you read. So if you integrate, not integrate, if you take how to find the pressure, pressure is force divided by area. You rearrange the equation, force equal to pressure multiplied by area. So how to get pressure? Again, you substitute the gamma here. Gamma is specific weight per float, Newton over meter, multiplied by area. Okay. So you know moment? Moment is force multiplied by perpendicular distance, F multiplied D. So if you take this one, the reference point here, and we have a force that go perpendicular to the surface, F multiplied by perpendicular distance, you get moment at this point. So Fy, Fy equal to moment at x-axis, moment at x-axis. Then you put in the force equation just now. So force equal to pressure multiplied by area. Force equal to pressure multiplied by area. Okay. So you put this one, rearrange this one, y square, and the gamma you push to the left, put outside the integration sign. So this sign, if you see integration y square dA, and this one is moment, you're taking moment in x-axis, mx equal to gamma is weight over meter, specific weight, multiplied by integration of y squared dA. So this one, the highlight one, is the second moment of area. Okay, second moment of area, or sometimes you call it IXX or IYY or IZX. Okay, so this is the thing lah. So if it's a moment of the area, so you will need to consider the area lah. Okay. Now we use I to represent the moment of area or moment of inertia in this case. So I equal to dI equal to y squared dA. So this is the first equation for today. Moment of inertia. Dix. This one is in the x direction. On the x means on the x-axis. Okay, you are referring to x-axis. I. So if you're referring to moment of inertia referring to x-axis equal to y squared over dA. dA is this surface. Okay. dA, then you see d something on the left, d something on the right. You know that the next step is integration sign. Okay. Same with IY. IY is the y-axis. So when you look at y-axis, there is a distance of x from y-axis to the area. Right? So don't confuse between IXX, IYY. Huh? So dy equal to y squared, x squared dA. Huh? So don't confuse between the IXX and IYY. Okay. So you do integration, you get the entire moment of inertia of the area. Okay. All right. So this is the important equation. Huh? If I ask you to find moment of inertia from x-axis, equal to integration y squared dA, Iy equal to integration x squared dA. This is on the for this area lah, and the 2D case. But 3D case, you need to consider volume lah. Okay, so another one is called polar moment. Polar moment is about a pole of O. So just now you're referring to IXX, IYY just now. Moment of inertia is from the axis. If the question asks you to solve moment of inertia is from the axis, x or y. But if the question asks you to solve polar moment of inertia, they are referring to one of the reference point from anywhere in the space. Okay. Now, the formula will be almost same. The left-hand side will be the inertia component. In just now, it's used I. But now, because of the question mentioned polar, you are changing the I become J. And on the right-hand side, still just now, moment inertia, you use X or Y square, but now you use the R. Okay. So now you have another one called polar moment of inertia. You use DJO because you're referring to one of the point, this reference point, equal to R squared dA. So same, if you want to find polar moment, you integrate R squared dA. From this diagram, are you able to relate R to X and Y? Are you able to relate R with X and Y? If you're able to do. So this is a right angled triangular here. R squared equal to X squared plus Y squared. So you rearrange the equation, substitute back to R. your polar moment of inertia you can write in x and y. Okay. So if you can imagine this one as a triangular, and R is a trigonometry, R is a hypotenuse, R square equal to x square plus y square. You see what I write on the whiteboard here? And you integrate. Do you see is equal to x plus ix plus iy? You see the form, right? Because your R square equal to what? X square plus y square. So you integrate this one. When you change this one, R square equal to x square plus y square, you break the integration, you actually get ix and iy. Okay, so when the question asks you to find polar moment, means you need to find ix and iy, or ixx or iyy. Okay, so this basically is the concept. Okay. Okay, the rest you read. Now we go into a theorem, which is very popular for your final exam. You will be forced to use parallel axis theorem to find the moment of inertia. So what I mean by parallel theorem, axis theorem, is basically you're referring to axis. X-axis always to in the straight line. So if you're referring a theorem, a parallel axis theorem, means you copy the parallel theorem to the position that you want to find. Y you can extend to y prime, x you can extend to x prime. So the rest you read. So here, if you want to find moment of inertia in x, you actually referring to x, and then this is the distance that you are going to find. So this is a centroid. Last chapter you already can know how to find the centroid already. Okay. So this one will come out in your test too. So centroid. But now we are more interested to find the moment of inertia with these small pieces of equation. So we want to find distance from x-axis. Ix is from x-axis. So here is y. So how to find the distance from here to here is this one plus this one. Okay. Here is dy plus y bar square. It's the same concept like what you learned just now. You're referring to the small pieces of gray color area. If ixx. Okay, ixx means from x-axis, refer to that one. Okay. So this one should be, you should able to understand. Okay, then you integrate. You get two components, y prime and d square. D square means distance from x-axis. Okay. So it become because this is square, so you have three components. You know that if you square, you have y square, 2yd, and d square. So you have three components. Okay. When you take these three integration products, so first integration, this one, represent the moment of inertia about the centroid of I bar. Okay, first this one is the moment of inertia to the centroid. Okay, to the centroid here. Okay. So it means this dA to the centroid. First component. Okay. Second integral is 0 since x prime axis pass through the area of the centroid. This one. So when you have an integration of your y prime is here, dA, and dy is here. So dy, okay. So y prime, you can just assume, not assume lah. The second term is 0 lah. The idea is the mathematic is 0 because this axis x prime pass through the centroid. Then the third one is area lah. You integrate area. So you can simplify the entire area with, if you're referring to centroid, not with centroid, there's a C point there. Then your Ix will become two components. One is because of the first integration, because of you are from the measuring from the centroid. Second one is because of the area, this one. So moment of inertia, when you use this one, okay, the one that you see over here is when you're looking at centroid. Okay, you use all this when you're focusing on centroid. Okay, you're focusing on centroid. But when you use this one, is when you are referring, when you use Ix equal to, we call it I, in dynamics, we just write Ig with the center of gravity, centroid, or IC, if you want. It's the same. This one in dynamic, you refer to table. But this one in statics, no choice, you have to calculate from here. Okay. Plus, this one is A d squared, dy squared. So x, you're referring to y. You're referring to y. Okay, this is the distance from x-axis. Okay. Then polar moment, again, polar moment is this one plus this one. Okay. Okay, in general form, when you need to use this one, is when your focus point is away from the centroid. Let's say I just put a point here, a mark P. This is a D. Okay, so you measure the distance from the P to C. So you need to use this one and not this one. This one is on the centroid. This one is when you have a reference point outside the centroid. Yeah. So we have all these things. The rest you read lah. The rest you read. So okay lah. This one you read lah. Moment inertia of the area. So there are two components. One is moment inertia about parallel axis passing through the centroid. So this one is pass through the centroid. Okay. So the first one is pass through the centroid. This is the first part that you learn. Pass through the centroid. Second part is a product of area and the square of the perpendicular distance between the axes. So perpendicular distance, so AD of the both axes. So if you calculate x is here. So perpendicular distance of x and dy, perpendicular distance. If you calculate x, okay, centroid to D. So if you calculate x, you're referring to x-axis, perpendicular distance to the centroid. If you're calculating y, you take the area, multiply the distance from y-axis, perpendicular distance to the centroid, and square it. Okay, so this is the difference between the previous one. Yeah. Okay. The next one is radius of gyration. Radius of gyration, when you use this one, when you have an unknown shape or non-uniform shape. For example, if you have a sphere or this one you know is a round shape. But what happened if I use a round shape and I cut something from here? It means or I add or I add some weight here. I just welded extra material here. Okay, so if I draw in 3D, you will see something floated above the surface here. So you cannot use, and in your table, IXX IY table, there's no shape like this. There's no calculation. You need to calculate one point to another point. So this one you use radius of gyration K to calculate moment of inertia. All right, you can calculate, but it takes times to do integration here and there. That one is more on the mathematics chapter lah. But in dynamic, we have no time to do all the integration steps. Straight away, you use the products. Okay. So gyration is the axis, blah, blah, blah. This one is to find the moment of inertia. Okay. So basically, this one, if you rearrange, Ix equal to a kx square. So if you want to find, but usually the radius of gyration will be given. All right. So you only need to find Ix. So you just rewrite this one. An area, this one is in 2D. If you have 3D, then you use mass. If you're given center of mass, you use mass. Okay, so the same. Kx is radius of gyration. Is Ix divided by A, then you square root it. If it's x, you refer to x. Y, then you refer to y. If it's a polar coordinate, then you use polar coordinate, polar inertia. Okay, so we have a few equations this morning. K okay, it depends on I direction. Okay. Okay, the rest you read as your homework. So in yesterday class, we introduced you case 1, case 2, case, like what you see on the screen. The one here you see is case 1. The rest you read lah. So if you see you need to calculate the centroid in this method, it's called case 1. You are using Ix equal to y squared dA. If second one is this one, this is case 2, vertical one. Okay, now we are seeing as a tutorial 1, you are seeing case 1, right? So he asks you, this is a simple case just for discussion. So you're seeing a rectangular shape. You are given a centroid. You're given x-axis, y-axis, right? So here, even though the x-axis, y-axis is not seen, but this is x, this is y. Okay. Determine the moment of inertia for the area shown in the figure respect to three cases. First one, respect to centroid here. B, respect to axis xb to x axis. Pass through the base, okay. C, it asks you to find the polar or z-axis perpendicular to xy plane passing through centroid. Okay. C not polar, P is pole to z-axis, which is coming up from the screen. So we are using case one solution because it's in this way. It gives you the rectangular area in this way. So this one you read lah. So for first case, we will use Ix equal to integration of y squared dA. Iy equal to integration x squared dA. Okay, this is a 2D case. So just recall this is case number 1. Straight away, we apply the equation. Because here is using y prime, so we just copy the y prime there. Moment of inertia from x prime, he asks you from x-axis, so you just copy from x-axis. So this is y prime square dA. Okay, expand the dA. How you find the dA of this one? You take dy prime, multiply by b. This is half b, half b. You total get b. So b dy prime, you get the area of this one. Okay. Then you add in the limit. You change area limit to become height limit. So height is from, because this one at the center, the one to the left positive, the one to the left is negative. So you are integrating from negative, not negative. You're integrating from, let's see, the y here. So you're integrating in y, not x. Y go up positive, go down negative. So you're integrating from negative because it's below c. So you're integrating from here. So negative h divided by 2 to h divided by 2. Okay, then you pull out the b and you integrate y. Okay. This one you substitute. You substitute dy. This one dy. Integrate y square. You will get y cubed divided by 3. Then you substitute h2 h divided by 2 minus h divided by 2. Minus you get positive. So at the end, you arrive at one answer. For rectangular, your Ixx at the centroid axis is 1/12 dh cubed. This is a standard. For rectangular, at the centroid, your Ix means this is x. No, this one is passed through the centroid, equal to half dh cubed. So this one is standard equation, like you memorize gravity 9.81. Okay. For static, just for info lah. But before you arrive at this one, for static, you need to write some equation like this. You need to write the step, then only you arrive at this one. So if you straight away give this one, there will be some marks missing for your working. But when you move to dynamics, you straight away give this one, you still get full marks because we already, you can refer this one to table, straight away from table. But static, you cannot use table for moment of inertia chapter. You need to derive, you need to write this equation. Okay. Part B, from axis, this one, we use parallel axis theorem because we are moving from centroid to another distance from the centroid. So we are using this formula, Ix plus I centroid plus AD squared. Okay. So you're looking something like this. So moment of inertia from XB equal to centroid moment of inertia, like you find in the section A here. All right. So I bar X prime is this one, 1/12 BH cube that you calculate. A is the area of the whole thing, or you can integrate these small pieces, integrate from half h to negative half h to positive half h. dy, this one is perpendicular distance from the xb, is here. This is the perpendicular distance from this axis to the centroid. Okay, so the first part, I bar x prime, if you don't understand, you refer to the previous slides. This one you derive from the part A. Okay. Second part, area of this whole thing is B multiplied by H. And the dy square is from perpendicular distance from the axis is H divided by 2. Yeah. You rearrange the equation, you will get 1/3 BH cubed. Okay. So if you are away from the centroid, x is s prime. So if you're away from G or centroid, it will be Ix equal to Ig plus A d squared. Okay, this is perpendicular distance. So this is the perpendicular distance. This is D. Okay. C from opposite axis come out from the screen. So because it's a z-axis, so we integrate both parts. All right. To obtain the polar moment inertia about point C, we modify Ix prime to Y prime. So because when it changes to Y prime, we flip the distance from the centroid to the y-axis. Okay, so the equation will change from the left-hand side to right-hand side. The derivation step still the same. You arrive at this one. Okay. So polar moment of inertia about point C is the product of these two, Ix plus Iy. So you add these two, you get the result lah. Okay, so this one is for rectangular. Of course, rectangular won't come out in your test. Too easy. Okay. Yeah, there are some lecturer will ask question like, why you give students so easy question? Okay, so I have to give you some tough questions, something like this. Okay, example 2, same concept. Just don't panic when you look at this question. Concept still the same. Determine the moment of inertia of the shaded area shown in the figure about x-axis. So about here. So about x-axis, first you find the centroid first. Where is the centroid of these things? Okay. So here it pass through this point, intersect with this point, and you're given one equation of this curve, y squared equal to 400x. So the distance here to here is x. So here to here is 100 mm. So you take 100 mm minus x is the distance, balance distance. Here to here is the center of the shaded area, Y. Okay. So the step still same. You try to observe the steps are always same. So you integrate the differential elements. Okay, you say identify the differential area. Okay, then you intersect with here at this point. This one is a standard one. You write this statement. You write differential area is to be parallel with x-axis. Refer to this one. The question. If the question asks you why, you change this one to y lah. Okay. Then you write is intersect at what point? At xy point. So the area is this one multiplied by dy. Okay, so dA equal to 100 minus x multiply dy. Okay, so these are the standard work steps lah. You write this one, then write this one, then find the dA from the diagram. Okay. Then you write Ix, this formula, Ix equal to integrate y squared dA. Then you modify a little bit. So this is Ix. Ix is from x-axis. Okay, y is here to here. Right? So y squared dA is the area that you find on the top here. Substitute there. Limit is from, because you are integrating what? You're integrating dy and not dx. So your dy, the total length of the y is from 0 to 200. This is your y. Okay, because your step here is dy. Your area is dy. So from 0 to 200 mm. Okay, you change from area limit to y limit. Then the rest is integration steps. Okay. So once you put inside there, because your dy, remember you need to use the y term. Change the x in y term. Y squared equal to 400x. Rearrange. X equal to something y. Put inside here, you will see this one. Okay, so rewrite this one. Then the whole integration works balance. And all the term inside there is y. So you can do the integration already. You cannot start integration when you have other terms, especially x. If you do not substitute, you are missing out the other parameter. You will get xy, and then you multiply x. So it's too late for the integration. Here got two components. You can integrate the front, or you can multiply inside there. Multiply, then you break into two integration. You plus or minus the answer. Okay, so at the end, you will get one answer. Look at the unit. The unit is something power 4. Moment in inertia is unit SI power 4. In this case, it's in mm because you're given in mm. If you're given in meter, then it become meter power 4. Yeah. Y power 4, you see the integration sign. Y square, y is in meter. dA is height multiplied by width. So you square this one, you get meter multiply another 2, you get 4 times of meter. Yeah, remember the unit. Okay, so case number 2. If the question forces you to use case 2 or solution number 2, you look the question as this case. So you transform the question into this case. You flip the triangular in this case. Of course, the question won't do something like this. It's either give you straight this way or this way. Okay. You look at the step. Actually, it's the same. It's only In this case, you are looking from y-axis and not x-axis. You see the steps. So we are transforming this one to this one, and I enlarge the diagram. Okay, I enlarge the diagram. Still the same. You need to identify how you calculate the dA. dA is x multiplied by the height of this one. It's intersect with one point here. This point is your y. And this is the center of the object, x, comma. X, comma, the distance from x is half of your y. Because it's rectangular, center always half of the object. So half y. Okay. Then you see what is the difference. The rest you read. Okay. The rest you read. Okay. So just now you find that the ix prime equal to 12bh squared. You identify your b as dx here. H is y. If you replace b with dx, h is y. Okay. Then you do the same equation. I equal to ix equal to I plus a d square. This one is from the rest you see from the slides here. Okay. The rest you read from the slides. So we're still referring to x. You just substitute the value of your distance and so on. You still get the same answer just now. It's just the step is a bit different. Okay. Example 3. This is method number 1. Okay. So if you look at this diagram, it's a sphere. There are two intersection points of this small section of area. So you have negative x, y, and xy. And this is dy. So this is a centroid. So to the left is minus x, to the right is positive x. This is y to the center of the particular element or intersection of the element. You're given the shape of that particular, the equation for that particular shape, in this case sphere. Sphere equation x squared plus y squared equal to constant value. Okay, first steps. If you use the first case of this one, horizontal element, straight away you write ix equal to y squared dA. So how to find dA of this one? You take dy multiply by 2x. Okay, you change dA to 2x. But again, this is the integration sign. Careless mistake is here. You need to change the x in y term. How you find the x y term is here. So here is x squared plus y squared a squared. So move your y squared to the right hand side, square root the whole thing. Substitute here. You arrive at the whole equation in the y term. Okay, so this is the careless mistakes usually in the exam. You will panic here. So this one you copy from the question. Okay, the rest is integration steps. So I won't go deep into how you integrate lah. At the end, you arrive at one answer. Okay. So this one is one number lah. It's one number, so it's 3.14 something. All right, 3.14. Okay, any question for Ix? No, huh? So this one, why we do not, this one is asked you to respect to x-axis, so that's why you use Ix only. If the question at respect to x-axis and y-axis, so you need to repeat this one. You need to write Iy equal to x squared dA. Okay, then you calculate Iy. Then if the question asks you polar moment of inertia, you take Ix plus Iy. Okay, yeah? Okay. You see case number 2. Case number 2, the differences. Case 1 is horizontal strips. Case 2 is vertical strips, but still the same. You see the strip is vertical, but you're looking at the intersection point first. One is xy, another one is x minus y. Identify the intersection point. Centroid is at the center here. Then dx is over here, and the length of these strips is y plus minus y. Okay. So you see the steps, huh? When you integrate, when you look at differential element, the centroid happen to lie on the x-axis, means the centroid pass through the x-axis. And since we know that rectangular, this one, rectangular, we already assume if you have a rectangular shape, the Ix will be 1/12 bh cubed. Okay, this one we already assume, you know already. We assume we already know every time you see a rectangular, Ix will be this one. So you already know Ix, if you refer to the centroid, you get 1/12 bh cubed for rectangular. So Ix equal to bh cubed. So what is your b in this case? Your b is here. This is your b, base of your rectangular. So b is dx. H is here. H is 2y. So you substitute your 2y here. Rearrange the equation. You get 2/3y cubed dx. This is this 2/3 cubed dx is you can say redundant because the question always change, but this concept is important. This concept is important if you use method number 2. So once you get your Ix, you integrate your Ix. So Ix equal to integrate, you change, remember, you integrate dx. So change your y in x term. You get this whole thing in x term. The rest you integrate, you get 3.14 a power 4 divided by 4. Okay. So this one is pi because you will see 3.14 something. It's a pi value. Right. Okay, so by comparison, this is just a quick way. By comparison, you have two solution, solution 1, solution 2. By comparison, solution 1, you requires for less calculation. So actually, method 1 give you faster calculation. Although solution 2 can also achieve the same answer, but right, because sometimes it pass through the, sometimes it's very difficult to find the centroid. Okay. Okay, we go into so this one is a 2D. We see what happened to 3D. 3D, we go into 3D, you will see the word composite. 3D is the same like what you learned in previous class. This one you read. This one you read. You see composite means more than one body. So here you can actually see it's a combination of rectangular minus a sphere there. Right. So you calculate 2ix, iy for these two shapes. Then you take the value minus each other. You see the steps, huh? You break into composite part, copy all the dimension. Okay. Then you use parallel axis theorem. You do one for cycle, one for rectangular. What is the equation for parallel axis theorem? You use I equal to ix plus ad square. When you use this one, when your center of something is away from the centroid, you're referring to x, right? So this one is got some distance. So when they got some distance, you use this equation. Unless the question asks you x at the centroid, then you don't need the second half. Yeah. So this one, um, this one, um, this one, how you get is by the integration steps just now. Okay, this one is a bit faster, a bit go very fast at this. This one is you assume you already know how to find this one, so straight away you get this one. A for circle is pi r square, multiply by dy. How you get 75 is from here. X to the centroid of circle. Rectangular also same. Ix plus ad square is away from this one, centroid. Okay, and this is a rectangular. So rectangular, again, we assume you already know Ix equal to 1 over 12 bh cubed. Yeah. Then, after you find using parallel axis theorem, you take this one minus this one. Okay, take this one minus this one. So there's a minus sign there. Another one, you look at the steps. Look at the steps. So here is a composite body. You can see this one as three shape: rectangular, 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 or small rectangular here, rectangular here, rectangular. Depends on how you see it lah. But got three body. So three body, there's a reference point there. There's an X there. So you see the work. So you break into three composite, A, B, A, B, A, B, and D. Why we skip C? Because C is a centroid. So you don't want to confuse ourselves with centroid. A, B, and D. Then after that, we do parallel axis theorem. Parallel axis theorem, we see from x-axis. Okay, I ask you y and x, right? So you need to do two. One is x, one is y. So A is away from x. So you will have ix plus ad squared. B is on the centroid. So no, your ad squared d is 0. D, you also have ad squared, but your d is below negative. But square, you still get positive value. The d is negative, but you square it, you still get positive value. Okay, the rest is the substitution. So rectangular A and D, you see the equation. A and D because it's away from the x-axis. So AD square, the distance is the same, 300 mm, 300 mm. So you can combine the two. This one, rectangular shape, 1 over 12 bh square, base and height. A is the area of this segment. D is the distance from x-axis. Okay. Any question for your AX? No, then you go to Y. Y, you're referring to y-axis. Still the same format, IY equal to AD square. But this one, IY is from the y-axis. Okay. So you get IX, IY for rectangular. You look at rectangular B. Rectangular B, you see you don't have AD square because it's happened on the centroid. The D is 0. Okay, the D is 0. So that's why you don't have. If you still want to write also can, but D is 0. Dx or dy is 0 because it's happened on the axis centroid. So once you have this one, you add all the moment together. But remember, this one you need to double it because this one is for one rectangular. Okay, you see the summation. So Ix is 2 of this one plus this one. Iy is this one, 2 of this one plus this one. Okay. If there is a positive surface, then the positive. If the one that you need to minus one, take away one, then negative. Like for example, this case. Okay, you see there's a negative value there. Suppose you should write this one first, then minus this one. This one minus this one. Okay. Clear? This one okay? Okay. So for example, I see this one. So if you see this example, you just calculate 2 2ix and 2iy. So this one, it already give you the centroid C here. So you need to calculate for the top one is distance here to here, here to here. For x, but for your y is 0 for the top. Iy for this one because it's at the center. Okay. Then for the bottom part, this C is a centroid for overall body, but this one is 150 height here. The center of this bottom one is not here. It should be 75 mm at here. So you need to measure It's somewhere here 75 mm here. So there's a D there, here to here, centroid to that one. So you're given the height of this one, right? So in the earlier, you didn't know how to find the Y bar. Right. This one you need to build the table. See, remember the table, component 1, then area, so and so, right? Okay, so with this, we conclude statics module. We already finish.